Hey guys, welcome back to my channel. So today we're going to be talking about converting from weight to mass or mass to weight. So the formula for weight to mass conversion in physics is big W for weight equals mass times small g. And small g is gravity, and it's different from planet to planet. So that means if you knew the mass of an object, and depending on what planet you're on, the gravity, the average gravity, you could calculate the weight. And if you knew the weight and the average gravity, you can calculate the mass. And if you know the mass and the weight, you can calculate what planet you're on based on what the small g's value is. So as you can see, I've put in some tables, or a table of basically the small g for our planets in the solar system. So this table is going to be the value for this, depending on what planet you're on. So let's do a practice problem. So what if I asked you, what is the weight of an object in newtons of an object on Mercury with a mass of 90 kilograms? So remember our formula. W for weight equals our mass times our small g. So it gives us our mass of 90 kilograms. Actually, let me do that in yellow. Mass of 90 kilograms. So we can replace m with 90. And then if you look up in our table what the value of small g is, for this specific problem, it says we're on Mercury. So that is Mercury's acceleration due to gravity times 3.6. If you go ahead and calculate that, you're going to get D as your answer to this first problem right there. Let's do another one. So here's another problem. We are on Jupiter, and the weight of an object is 250 newtons. What is the mass of that object? Good question. So let's remember our formula. Work equals mg. Or not work, weight equals mg. So we know our weight is 250 newtons. So that can go there. And then that equals m. And yes, since we're on Jupiter, we can figure out, based off of this table, what our acceleration due to gravity is. So looking at the table, this is the thing for Jupiter. So mass times 26. And that's meters per second. D6. So divide 26 on both sides. Divided by 26. And your mass of the object is going to be equal to about 9.62 if you type that in your calculator. 9.62. So there you have it. That's one other good problem. Let's do one last and final problem. So our next problem is an object on Earth has a weight of 150 newtons. On which planet? So we're solving for G. Which planet would the same object have an approximate weight of 170 newtons? Don't let this trip you up. Think about it. Same object, mass is constant. So that means you have weight equals mg, and then it's 150 newtons, and that's going to be equal to our mass, and we're on Earth, so it's going to be 9.8 divide by 9.8 on both sides, and you get that the mass is equal to about 15. So remember that mass is constant. So now, you have weight equals. Actually, let me do it in a different color. Let's do purple. Weight equals mg, and so we know that we want a weight of 170 newtons, and we know our mass is constant. It's about 15 times g. Divide by 15 on both sides, and you get that g is equal to 11.3 repeating. And now, if you look up at the table here, the closest planet to 11.3 repeating is Saturn. So our answer is B here. The answer is B. Thanks for watching this video. Hope to see you soon. Have a safe, wonderful, and happy day.